low air pressure in the tires, only about 15 pounds of air pressure. And the vehicles are built here in Alberta, in Calgary, by a company called Foremost Industries. Foremost. This company mostly builds vehicles for use in the oil industry. But since the early 1980s, Foremost has built 22 of these Ice Explorers for us. They have built one other, and it's in use in the Antarctic at the McMurdo Research Station. And we have a special greeting here. When we go past a Ice Explorer, give them a moose wave. Moose wave. That's a hand on either side of the head, and you can wiggle your fingers. So give them a moose. Moose. You can do a moose crawl too. Moose. I'm just going to have to wait here a moment. Again, part of the road in front of us is just wide enough for one-way traffic. So that steep hill we just came down the moraine. The moraine. M-O-R-A-I-N-E. Moraine. Moraine is just rock. Rock that the glacier has dragged along its side or pushed in front of itself, and then later it melted back and it left all this rock behind. So this huge moraine continues on our left, and there's another one on the front right. The surface of the glacier was as high as these moraines in the early 1800s. So in places, the glacier has melted down at least 100 meters. But we actually are on the surface of the glacier, though here it is covered with rock, as you can see. This part of the glacier has a thin layer of rock, maybe about 30 centimeters of rock. Below the rock, there's about 30 meters of ice. Though the glacier is going to get much, much deeper as we travel towards the middle. Okay, let's give another moose.
Want me to close it? Just ask, okay? Okay.
Sounds like a train whistle. In front of us we have a little pool of water to go to. That is quite deliberate. We've shaped the road so one of the streams will spread out. And we want all that water there so we can rinse the mud and the dirt from our tires. Because if we were to take a lot of dirt onto the glacier road, that dirt being dark and in a thin layer, it would absorb heat and would cause the glacier road to melt faster than the rest of the glacier. So we rinse our tires here. Now you look at the water here, it's not very clear. You wouldn't want to drink this water, but it's already starting to pick up some dirt. But you'll watch, as you go further up the glacier, that water will get clearer and clearer. So now, this is not snow we're on, but glacier ice. This is ice that was formed hundreds of years ago. This ice can be anywhere from about 100 to as much as 800 years old. Oh, I was too slow there. So the glacier starts from the head wall. Again, the really steep part of the glacier at the end of the valley, the head wall. And then it goes all the way down the valley and ends down below us, what's called the toe of the glacier. From the top of the head wall to the toe, it's about 6 kilometers long. From side to side, it's about 1 kilometer wide. And again, the far side's covered in rock. And where we stop, that's the deepest part of the glacier, about 300 meters thick, 300 meters of ice. So that's the size of this glacier. Though this glacier is rather small when compared to the much larger Columbia Icefield. Again, that icefield begins just where the head wall becomes flat on top. An icefield is a very large glacier. And icefields are unique because they feed other glaciers. They're the source of other glaciers. There's about 30 different glaciers flowing off of the Columbia Icefield. And 8 of those glaciers are very large like this, what are known as an outlet valley glacier. Outlet valley glacier. So the Athabasca is a particular type of glacier. An icefield is another type of glacier. So we're on an outlet valley. And it just means that the valley acts like an outlet for the ice to flow out of the ice field. I'll show you a couple more glacier types as we go. Now, there are other ice fields in the Rocky Mountains, maybe about 12 other ice fields, feeding even more glaciers. But the Columbia ice field above us here is the largest ice field in the Rocky Mountains. It covers an area of around 325 square kilometers. That would make it larger in area than, say, a city the size of Vancouver. So the Columbia ice field is about 50 times larger than the glacier we're on. Now, the ice of a glacier, it's different than what we normally think of as ice. Say, ice cubes in a freezer. That's frozen water. Whereas the ice of a glacier is made from snow. All the ice that makes up this glacier was once snow that sat on top of the Columbia ice field a long, long time ago. Every year, up on the ice field, about 10 meters of snow falls. Now, down on the glacier here, the snow from the previous winter melts away each summer. So there's very little snow on the glacier. But up on the ice field, it's cold enough there that snow just keeps piling up. Every time there's a fresh snowfall, that new snow will land, and it compresses the snowpack that's already sitting there. And then more snow falls and more compaction. In about 10 years, the snow turns into solid glacier ice. But just due to the sheer weight and volume of all that ice, gravity, and wherever there's a gap in the mountains, as there is here, down that ice comes to form a glacier like this. The most basic definition of a glacier is moving ice. This ice is all moving downslope under the force of gravity. Now, over on our left-hand side and above us are two more glaciers. Well, they're much smaller than what we're traveling on. The first glacier is directly on our left and above us. That's an example of a hanging valley glacier. Hanging valley glacier. So there's another type of glacier. It just means, as it sounds, it sits in a little valley that hangs above this valley. The name of that first glacier is the AA Glacier, called that because it sits right between two mountains that start with the letter A. So to the left of that glacier is Mount Athabasca, and to the right of that glacier is Mount Andromeda. So in between the AA Glacier. A little further on our left is another glacier. This second one is called the Andromeda Glacier, as it sits on the mountain of the same name. And that's an example of a cirque glacier. A cirque is that bowl or basin that the glaciers carve right out the middle of that mountain. Now, these two smaller glaciers are also independent glaciers, meaning that they're independent of an ice field. They're not being fed by an ice field. So a glacier does not need an ice field to begin. But they have formed in the same way, just on a smaller scale. So snow will collect up on the summits of those mountains. At that elevation, it doesn't have a chance to melt. Instead, over time, it compresses into ice, and gravity brings that ice down. But all the glaciers of the Rocky Mountains are getting smaller. As our climate warms, they're melting away faster than they're advancing forward. They're receding. In the case of the Athabasca Glacier that we're on, it's getting shorter each year by 10 meters, or about 30 feet. And it's been melting back like that since the middle 1800s. Most glaciers around the world are receding, again, reacting to our warming climate. But something that you notice with the Andromeda Glacier on our left is all the cracks in the ice. Crack in a glacier is called a crevasse. Crevasse, a little bit different word than a crack in rock, which is a crevice. And at times those crevasses will split their way through the depth of the glacier and huge blocks of ice break off. It can make quite a noise. It almost sounds like thunder. Now, we don't take you as far as the head wall. Again, the head wall is that really steep part on our front left. That is the most dangerous part of the glacier. The ice comes out of the Columbia ice field and flows over 3 steps in the bedrock. And that, too, is causing the top surface to stretch and crack apart. The head wall is one huge crevasse after another. And those cracks are about 10 meters wide by 30 meters deep, large enough to fit all of our Ice Explorer vehicles within a single crevasse. So we stay well back from that head wall. But we're just coming to the end of our road now. This is the deepest part of the glacier. As I mentioned earlier, there's about 300 meters, about 1,000 feet of ice below us. We're going to stop here. We have until 4:05, 5 minutes after 4 o'clock. Current time's about 3:38. So we have about 27 minutes from now. Feel free to return to the coach when you like. The stairs stay down and the door remains open. Or for that matter, if you just rather remain on board, of course you're welcome to do that. Now just a few things that we ask for your own safety. First, please stay inside this leveled area. Do not go past that line of blue cones at the front. Beyond there are large cracks and holes in the glacier. So stay in this immediate area. We also ask that you don't come right where I am now, at the back of the parking area. Coaches are constantly pulling in and out of here, and as you can see, it's particularly wet at the back here. So just stay along the outside edge of our front area. And of course, we ask that you not leave any litter, any garbage on the surface. If you have any, you can just throw it into the pail up front here. Again, the streams around the outside edge of our parking, that's very pure and, as you can imagine, cold water. Our coach is numbered 549, and the number's also on the outside windows. The temperature is about 8 degrees plus a wind chill. And again, we have until 5 after 4. Enjoy your time here.